Good day, everyone. Today we shall be considering indices theory, which is exponential equation. Under this study, we shall be considering simple exponential equations leading to quadratic equation, and then relevant exercises. Exponential equation. That's what we shall be considering now. An exponential equation is an equation that has a variable in its exponent or in its power. What simply means is this. For instance, let's take this for instance now. Let's say I have 7 raised to power x is equal to 49. And this is an exponential equation. Yes. The reason is because this 7 has an exponent, and that exponent is a variable. It could have been any way actually. It can be 7 raised to power 2x. As long as there's a variable there, that makes it an exponential equation. And so the basic idea about exponential equation, how we try to solve exponential equation, is to ensure that we have either a common base, or we have common exponents. That's how we. So let's take the following examples actually, and we'll see how we go about them. So example 1. And so let's look at these questions. Now example 1 says solve the following exponential equation. 2 raised to power x equal to 64. And then the B says 1 over 2 raised to power x equal to 8. And the third one says C, which is 3 into the bracket of 3 raised to power x, close the bracket, equal to 27. So let's take the first one. How do we solve these first questions now? We have 2 raised to power x is equal to 64. This is quite an easy one. The first thing we simply do is that, what can I make common here? Well, the base is what you should make common here, because the base on the left hand side has 2 there. And then on the right hand side, can I turn the 64 to 2 raised to power anything? Yes, from our knowledge of multiples of numbers, we have that 64 is 2 raised to power 6. I'm going to use 2 so that I will have common base. So I can say now that 2 raised to power s and then 64 can be written as 2 raised to power 6 actually. And now we see we've gotten common base, and all we just simply do is eliminate the common base. And that's all. So we have the equating the powers now. So x is equal to 6. So quite an easy one. And look at the b now. Let's solve the b. The b is 1 over 2 all raised to power x is equal to 8. The first now we simply do is to say that, remember that 1 over 2 is written as 2 raised to power minus 1. 2 raised to power minus 1. Then into bracket, then the x still remains. So I've turned the 1 over 2 to 2 raised to power minus 1 now. It's equal to, now I have 8 here. I can still write the 8 again, So open up the brackets using our knowledge of indices. I will have 2 raised to power minus 1 times x will give me minus x is equal to, now the base on the left hand side is 2. Can I turn 8 to 2 raised to power anything? So I will have common base, and absolutely yes is the answer. So 8 is 2 raised to power 3 actually, and then I will eliminate common base. So I can say now that minus x is equal to 3. And if I divide both sides by minus 1, if I divide both sides by minus 1, I will have x over minus x over minus 1 is equal to 3 over minus 1. And so I would finally have x being equal to minus 3. And the reason is because minus will eliminate the minus here, and I will have x left. 3 over minus 1 is minus 3. So lastly, the third one. We have 3 into the bracket of 3 raised to power x being equal to 27. And so here now, what we basically do here is we have different way to solve actually. And I can choose to say this 3 here is same as 3 raised to power 1, and the bracket means multiply by 3 raised to power x being equal to 27 and 27. So from here I can have, using knowledge of indices, this 3 raised to power 1 plus x equal to, the 27 can be written as 3 raised to power 3. So you see we've gotten common base now. Eliminate the common base. You have 1 plus x, equating the exponents now, equal to 3. And when you move 1 to the other side of the equation, we have x is equal to 3 minus 1. And then you can say s is equal to 2. So this is quite an easy one. We'll take example 2 briefly. So the question here is, find x in the following exponential equation. Well, quite an easy one as usual. So what we have here is, for the first one, 0.25 raised to power x plus 1 being equal to x plus 1 being equal to 16. First of all, I will convert this to fraction. So decimal to fraction, that will be 25 over 100 all raised to power x plus 1 being equal to 16. I know that 25 can go here 1, 25 can go here, give me 4. So I'm left with 1 over 4 being equal to 1 over 4 exponent x plus 1 being equal to 16. So I know 1 over 4 is 4 raised to power minus 1. 4 raised to power minus 1, that is 1 over 4. So into the bracket of x plus 1. So equal to 16. So 16. I can open up that bracket of that power now, and we have 4 raised to power minus x minus 1. And then this 16 cannot be written as 4 raised to power 2. And then let's bring the solution here now. We can say if we eliminate common denominator, common base, sorry, I will have minus x minus 1 being equal to 2. Being equal to 2. And then we can say move the s to the other side of the equation. S comes here, and then the 2 come to this other side. So I have minus 1 minus 2. So I have that x is equal to minus 3. That's the solution. So let's look at the second one now. 4 over 2 raised to power x. 4 over 2 raised to power x. We have 4 over 2 raised to power x being equal to 64. So like I said, these questions are easy. So what we basically do here is to say this 4 here is same as 2 raised to power 2 over 2 raised to power x, as usual. I've changed 4 to 2 raised to power 2. So equal to 64. And basically, we can also say that this, using the divisibility law, we can say this is 2 raised to power x, 2 minus x. And then from here, I've combined the 2, 2 raised to power 2 divided by 2 raised to power x is same as 2 raised to power 2 minus x. So that's what we have here. We have 2 minus x is equal to 64. 64 itself can be 2 raised to power 6. And then we now have common base. Eliminate the common base. I will be left with 2 minus x being equal to 6. And that being the case now, we can proceed to say, move the x to the other side of the equation and bring the 6. So we have 2 minus 6 is equal to x. So x is equal to minus 4. And so lastly, for the last part of the question, C. And so what we have here now, x is to the power 4 equal to 81. I'm going to ask myself, can I change 81 to anything raised to power 4? And for our knowledge of multiples now, I can say that 81 is 3 raised to power 4. So you see now that right here, we have common powers now, or common exponents. You can eliminate the exponents, eliminate the common exponents. So we have that x is equal to 3. So the next thing we want to look at now is exponential equation leading to quadratic equation. Exponential equation leading to quadratic equation. Okay, so we are looking at exponential equation leading to quadratic equation. So look at number 1 now. 5 raised to power 2x minus 26 into bracket 5 raised to power x plus 25 equal to 0. And so what to do here is to write this as 5 raised to power x, then in brackets the 2 outside, minus 26 into bracket 5 raised to power x plus 25. Now, why did I do this? It is because I could see 5 raised to power x in the first equation, 5 raised to power x in the first equation, and I want that index to come out in the entire equation. So I want it to be common in the entire equation. Now I can now say let p be equal to 5 raised to power x. And if that happens, we can now have Anyway, I see 5 raised to power s, I'll put p there. So that would be p square minus 26p plus 25 equals 0. And this becomes a quadratic equation, and we can go ahead to solve this quadratic equation. And so, to factorize this will give us p square. I'm just going straight to our factorization method. P square minus 25p minus p plus 25 equals 0. By now, if I expect you to be able to solve quadratic equation. If you don't know that, you can watch our video on quadratic equation. And so now we have factorization now. P minus 25 minus p, sorry, minus 1, not minus 1, then p again minus 25 equals 0. And so we have p minus 25 and then p minus 1 equals 0. So you can say p minus 25 equals 0, or p minus 1 equals 0. And then we can say p is equal to 25 now, or p is equal to 1. But you can see that the question didn't begin with p. We began with x, actually. We just have to introduce p. You have to be able to solve the exponential equation. So it is s actually I should look for. So what I will just simply do is to recall. Recall that p is equal to 5 raised to power x. And when p is 25, we have that 25p is equal to 5 raised to power x. And then we can solve this exponential equation now by saying 5 raised to power 2, which is 25, is equal to 5 raised to power x. And then we can then say, eliminating the base, common base, we have that x is equal to 2. Or when p is 1, we can say that I will do here. When p is 1, say 1 is equal to 5 raised to power x. And that 1 is same as 5 raised to power 0. Mind you now. So we can have it as 5 raised to power s. I use 5 raised to power 0. I can use any other number, but in this case I must use 5 because it is 5 raised to power s I have. So that one I'm using. I want them to have common base. Eliminate the common base, now I get that s is equal to 0. And so that's that about that. Let's look at the number 2 now. And so look at this question now. Same thing. I'm seeing 2 raised to power x here, and I want that to come out in the entire equation, or that to be common in the equation. So I'm simply going to say now that from the first term I have here, which is 2 raised to power 2x plus 1, I can convert that to 2 raised to power 2x multiply by, I will use a dot, multiply by 2 raised to power 1 on the first, using the first law of indices, then minus 5 into 2x, 2 raised to power x, then plus 2 equals 0. Then this can be written as 2 raised to power x now, 2, then times the 2 raised to power 1, which is 2, minus 5 into 2x plus 2, which is equal to 0. I can now say let p, I can use any other letter actually, let p be equal to 2 raised to power x. And then I will have p square now multiplied by 2 minus 5p plus 2 equals 0. And then that's 2p square now, 2p square minus 5p plus 2 equals 0. So we can solve this quadratic equation now. So I'm just going to pause and just solve the quadratic equation. So carefully solving, we get p equal to 2, or 2p equal to 1. And that will give us, that will give us p equal to 1 over 2. P equal to 1 over 2. So P is equal to 2 or P equal to 1 over 2. But P is not what we are looking for. Remember, we said let 5 raised to the power S be P. So I can say now that recall not 5. So recall that 2 raised to the power X is equal to P. So in that case now, when P is 2, we say 2 is equal to 2 raised to the power X. Actually, this can be written as 2 raised to the power 1 because 2 is 2 raised to the power 1 equal to 2 raised to the power X. And we can make common terms. And then we get that S is equal to 1. Or again, or when P is half, 1 over 2 equals to 2 raised to the power X. We can have 2 raised to the power minus 1 being equal to 2 raised to the power X. Elevating common terms will give us X being equal to minus 1. So that's about that. Let's take the last one. Okay, so using this now for this number 3, the same approach, the same idea. I just bring out 2 raised to the power X from the equation. So this will give us 2 raised to the power X all squared plus this will be 2 raised to the power X multiplied by 2 raised to the power 1. Then minus 8 equals 0. So I can say now let 2 raised to the power X be T. You can't use let 2 raised to the power X be X again because you have X meaning 2 different things. So, but you can say Y, for instance. You can say T, anyone. That Y square plus Y multiplied by 2, because 2 raised to the power 1 is 2, minus 8 equals 0. So we have Y square plus 2Y minus 8 equals 0. So I can factorize this now. So to factorize this, will you say Y square minus or plus 4Y then minus 2Y minus 8. So I will just go straight to the final solution of the quadratic equation. And so you can see we have Y equal to minus 4 or Y equal to 2. Well, but recall that 2 raised to the power X actually is what we called Y. When Y is minus 4, so we can say 2 raised to the power X is equal to minus 4. Well, this is unsolvable. We cannot solve this actually because of the negative value. But you see, when Y is 2, we can say 2 is equal to 2 raised to the power X. And then that 2 is 2 raised to the power 1 actually. Is equal to 2 raised to the power X. X is equal to 2. S is equal to 1, sorry. Take note. S is equal to 1. So that's all. I want you to take note of something here. The reason why we cannot solve this is because of the minus 4. The minus 4. You cannot say it is minus 2 raised to the power 2. Minus 2 raised to the power 2 actually is 4, not minus 4. So there's no number we can use. That happens to be a complex number, a complex value. So we cannot solve it like that. So that's about that actually. There are times also, you will solve the quadratic equation and you're getting something like maybe 3. And you say let P be 2 raised to the power X. And then you now have to say 2 raised to the power X is equal to 3. 3 now cannot be 2 raised to the power anything. There you can use logarithm to also solve. So that's about that. Try the following exercises.